Hello, this is going to be our second demonstration on contouring with Prismatic Machining in CATIA 3DExperience. This one is going to be of this design that I made of a logo for our class project. It stands for Designer Hills, which is the fake company name I've given myself at the beginning of the school year. So the first thing we're going to do is we're going to come in here and we're going to open up Prismatic Machining. Maybe in a later video we can do the pocketing on this, but for right now we're going to do the contouring around the outside. So since we have our product already in place, let's go ahead and pick a machine. We'll use the basic 3-axis. We'll select OK. Next we're gonna pick out our rough stock. So we're going to create some rough stock because we want to machine this out of something, so we need a little bit of rough stock, which is usually in the form of a billet, plate, or aluminum sheeting. This is 3/4 inch, so it's probably going to be billet. We want to select our 3D shape first off. Yes, we want to create some geometry. Secondly, we want to select our part body. And then the third thing we want to do is we want to make this just a little bit larger so that we've got material to come out. So we're going to go with 12 inches on the length. And it's 8 inches wide, so we'll go ahead and go with 9 inches. It gives us a little bit of exterior to work with so that we can cut this out. Let's select OK. Edit the part operation. So we're going to come in here. We're going to select our design part. Come over here to the skill tree. Select our part body. Come over to no man's land. Double click. Yet again, we would normally put a fixture here, but we're using a suction table. So we're simulating a suction table, so we shouldn't need a fixture yet. Next, we're going to pick our rough stock. Here's our rough stock in the tree. Double click it. No man's land. Third, we're going to pick our safety plane. I created the safety plane already when I created my datums. I'm going to select our safety plane. Then we're going to select OK. Yet again, we don't have a tool for this one because the previous one I used a 1 inch, and 1 inch is not going to fit into these radiuses. So what we can use to fit into these radiuses, because these are a 3/4 inch radius, is we're going to use actually a 1/2 inch radius end mill. And the specs for one of those. So we're going to come here, we can change this to 0.50 inch diameter end mill. Yet again, as I showed you before, I pull all this information off of Haas's website, and I'm going to use a Haas 1/2 inch end mill. So for its geometry, we need to enter in the geometry. So the cutting diameter is 0.5. The radius on the bottom here is an 1/8 inch, so 0.12. Our overall length, very similar to the one before, is 3.0. Most tool companies create a standard and they stick to that standard. Depth of the maximum cut, just like before, is 1.25 inches. Oh, I hit enter instead of hub diameter is 0.50. Because these are usually just a straight shank that comes out. We would have our carrier that connects the two together. Rounded. Shank lengthening. We'll come down here to technology. Yet again, this is a 3-fluted one. Right hand. We'll do a finish pass on this. Carbide again. 37 degrees on that rake. Maximum plunge. Maximum machining length 1.25 inches. Life expectancy doesn't have that information. Yet again, here's where we'd add our speeds and feeds information that you can also pull from the website. But for this exercise, those are unnecessary. But I will come down here to feeds and speeds since we're using aluminum yet again. I'm going to select aluminum, profile contouring, and we're going to do finishing pass. Compensation, like I've said before, is the amount further down you want the tooling to go into the material. This will account for any kind of edging that you may have experienced. The attachment, like I explained before, is going to hold this into the spindle of the NC machine or CNC machine, and we get to choose our colors. We'll select OK. We will select OK again. Now we've got it in our spec tree, so we can close this out. Yet again, like before, we will not need a whole search for right now. We will come back to that in a different program or a different video. We're going to come straight down here to program. We're going to go with Prismatic Machining selection, and we're going to select the profile contouring again. Selecting between two planes, we're going to click the check mark. The tool, we're going to use this tool. The geometry, select the bottom plane. We've selected the bottom plane. Now that we have the bottom plane, let's select the top plane. This is going to be the top of the plane of what we're cutting out. Yet again, we can adjust all of our limits here of how far we want this to plunge in and out of the thing. These will be things that we would learn later. And from here we can go ahead and select simulate just to show you what would happen here. So we're going to slow this down like before, and you can see here the axis is over there. That's the machine's home. For some reason it picked a spot over here. May have to learn a little bit more about this and learn exactly where these tool paths can start and really define that, because the time that you spend having this machine coming all the way over here versus coming down here is going to save your company a lot of money in the long run. But for this sake, we're just going to go ahead and select play to show what we're doing. You see it comes around and cuts it out. We'll come in here, we're going to hide our rough stock. And you can see it makes a contour and comes down and in and follows the line of the path of the part that we've already selected. Come over here to settings. Just like play. You can see it moves very fast. This program is set up for very, very fast. Let's see if we can slow this down just a little bit more. Come back to the beginning. Nope, we're not able to slow this down anymore. But as you can see, we've accomplished our goal. Thank you. I hope this helps. Have a nice day.